This is a video for AQA Further Pure Mathematics. This is Sequences and Series section 3.2, where we're looking at some more Maclaurin series of standard functions. Well, we saw how sin x could be approximated by a Maclaurin series, but there are many other functions that also have Maclaurin approximations. Just a couple of examples of them now. This one shows the approximation up to power 6 for cosine of x. You notice it's actually sort of similar in a way to the sine x one that we had, but this one has even powers of x, whereas sine had odd powers of x. You might be familiar with the idea that cosine is an even function. It's reflective in the y-axis, and sine is an odd function. So it's perhaps not surprising that the powers of x should be even in the cosine approximation and odd in the sine approximation. So that's sine and cosine that we've met. Another one that a function that you'd be familiar with is e to the x, and here's the approximation e to the x up to the cubic term. So we've got 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Now there are a group of things that you should be familiar with then. E to the x that we've just talked about, 1 plus x squared over 2 factorial, and that's true for all values of x. There's another one for the logarithm of 1 plus x, which is x minus x squared over 2 plus x cubed over 3. So you can see how that one changes sign, so we get this negative 1 to the power r plus 1 in there, which is the thing that changes the sign. Otherwise it's just powers of x over the power itself, so x cubed over 3, so the next term will be minus x to the power 4 over 4, and so on. That's only valid for x between negative 1 and 1. Sin x, the one that we've met, which has got the odd powers, and cosine x with the even powers divided by the factorials. There's another one which is 1 plus x to the power n. That one you may already have met in another context. 1 plus nx plus n minus 1 over 2 factorial, so you see the factorial there coming in, x squared, up to the rth term, which is n minus 1, n minus 2, n minus 3, etc. And then you've got r factorial on the bottom line. And that's true for the values of x, modulus of x, which are less than 1. So there we are, the whole range of functions that you should be familiar with, the Maclaurin series. You don't need to learn them, you'd be given them in the exam. However, you should be familiar with them, and in particular the range of values for which they are true. So these are the standard functions, and you need to know how to manipulate these to give expressions of slightly varying functions. So as an example of that, let's look at e to the minus 3x up to x cubed. So to do this we can simply use the standard Maclaurin expansion for e to the x, which is given here, and then substitute where we see x minus 3x. So we're just going to substitute into all of these places minus 3x. So the expansion then for e to the minus 3x will be equal to 1 plus, now I put the minus 3 and any term that I'm going to substitute into brackets. So I get plus minus 3x and then minus 3x all squared over 2 factorial plus minus 3x all cubed over 3 factorial. We don't need to go any further than that because we're asked to go to the term in x cubed. Having done then that, it's just a matter of simplifying this expression, so it becomes 1 minus 3x and we've got minus 3x all squared, so that's 9 plus 9x squared, so plus 9x squared over 2. And then minus 3x cubed is going to be minus 27x cubed, but we're dividing by 3 factorial, so one of the 3's cancels, and so we get minus 9x cubed over 2. So the process then is to use the standard expansion for e to the x, or indeed for any of the other expansions if we were asked to do a more complex expansion. And here we have the e to the x, and we're substituting minus 3x wherever we see x. So it's just a case of substituting those and then simplifying the expression as we've done here. Now let's consider a second example then. This time we're asked to find an expansion up to the term x to the power 4 for log of 1 plus 2x. Well, we know that the Maclaurin expansion for 1 plus x is given by this expression. So we've got the powers alternating sign, negative and positive, and then each power divided by its actual power, so x cubed over 3, x to the power 4 over 4, etc. So again, if we want log of 1 plus 2x, then we simply need to substitute 2x into this formula. And there it is. Instead of x, we're writing 2x, and then we can evaluate that. So this time it becomes 2x minus 2x squared plus 8x cubed over 3, etc. And up to the 4th power, it stops at minus 4x to the power 4. Now what we should then ask ourselves is, what values of x is this valid for? Well, we can take this from the formula that we're given. So therefore, instead of x in this, we've got negative 1 is less than 2x is less than or equal to 1. And therefore, we've got that negative 1/2 is less than x is less than or equal to 1/2. So it's valid for that range of values of x. Well, similar manipulations can be done for all of the standard Maclaurin expansions that you need to be familiar with, and also we can look at combinations of the functions, and that's what we'll be doing in the next video, which is on composite functions.